In this video, we are going to focus on Venn diagrams. Venn diagrams are used to show the relationship between two or more sets of objects. In this case, we are going to focus on two. A Venn diagram is a pictorial representation of a two-way table without a total row or column. This to the left here is a skeleton of a Venn diagram. A set is a collection of things or numbers that belong to a well-defined category. The sets, which are the circles, sit inside a rectangle called the universal set. The whole population here is everything up for consideration. This is generally the total number of people that have been surveyed. We have two categories here which will be named at the top. The overlap is the people or objects or whatever is up for consideration that share both interests on both sides. They have an involvement in both categories or topics being considered. And the outside is the objects or people that have nothing to do with or no interest in the objects up for consideration in the Venn diagram. To further explain that, I have an example here about 100 people, that's the population, that was surveyed to see if they liked maths or English. The survey brought up information showing that 33 people liked maths and 61 people liked English and 34 liked neither maths or English. To figure out the numbers in the inside, we have 28 people that like maths or English, 5 that like maths only, and 33 that like English only. Let's now take a look at this question. It says a group of students was asked to nominate their favourite food, spaghetti represented as an S, or lasagna represented as an L. The results are illustrated in the Venn diagram. So let's take a look at this. The whole population is the number of students that was surveyed. We know that 5 did not like lasagna or spaghetti. They sit on the outside. So this is the neither category. We know that S for spaghetti, 11 students like spaghetti only, 9 students like both spaghetti and lasagna, and 15 students like lasagna only. These numbers up here tell you how many students said they liked spaghetti regardless if they liked it only or both. If you add 11 and 9 together, you will get 20. This is the same for lasagna. This is the amount of students that said they liked lasagna, regardless if they liked both or just lasagna only. If you add these two numbers here, you will get 24. The question is, what is the probability that a randomly selected student prefers spaghetti? So we go P bracket S bracket equals fraction line. We know the whole population is 40. That means that that goes down the bottom here as the denominator. Now what we have to do is have a look at how many students like spaghetti. Now spaghetti is up here. This doesn't ask us whether they like spaghetti only or either or. There are 20 students here that like spaghetti, and of course we have to simplify, and that will go down to 1/2 because 20 is the highest common factor, goes into itself once and into 40 twice. Let's take a look at this question here. I'm going to read it and I'm going to fill in the Venn diagram as I go through the question. It says 10 girls went to the beach, 7 went swimming, while 6 tried fishing off a pier. If all girls either went fishing or swimming, how many just went swimming and not fishing? The first thing we have to do is place the whole population of 10 in the circle outside the rectangle at the top right, because we know that there was 10 girls. On the top of the first set, which is this circle here, I've written S for swimming, and then I've written an F for fishing. Now I know that there was 7 girls that went swimming. it tells me here 7 went swimming. It also tells me that on top of the second set here for F for fishing, that 6 went fishing. And it says it here, 6 tried fishing off a pier. The next part we have to do is find the overlap. That's the part in the middle there. So what we have to do is add 7 and 6 together, and that gives us 13. And then we go 13 minus 10, and that gives us the overlap of 3. I'll repeat that. Once you know these tallies up here, these totals of how many went swimming and how many went fishing, you add them together, which will be a greater number than this one here, and that is 13. Take away the population of 10, and it gives you 3, and that is your overlap. So you place the 3 in the middle. To find out how many went swimming only, you calculate 7 swimming minus 3 that did both, and you get 4. That tells me that only 4 girls went swimming only. And to find out how many went fishing only, you calculate 6 fishing minus 3 who did both, and you get 3. Because the question doesn't tell me that there were girls that did nothing or neither, this outside here does not exist. There's no need for a number to go there. If we are going to ask some questions, just for example a probability question, and we ask for the probability of girls that went swimming only, so we go probability, the event we're looking at here, which is swimming only, equals fraction line. There are 10 girls that went on this trip, and we know that 4 went swimming only, and then we would simplify that down to 2 over 5. If we ask the question of the girls that did both, so I'm just putting both in this bracket, we know that there was 10 in the population that went, 3 did both, swimming and fishing. Let's now take a look at this question here. It says, in a Scouts club of 24 boys, 14 have their orienteering badge, 17 have their cooking badge, and 5 have no badge at all. Draw a Venn diagram to find out how many have both orienteering and cooking badges. Well, the first thing I know is there's 24 boys, and 24 goes up here in the whole population because that's the total number of boys being considered in this Venn diagram. I have to write O for orienteering, and I have to write C for cooking. I've been told that 14 have their orienteering badge, so I put 14 up here. I've been told that 17 have their cooking badge. I've been told that 5 have no badge at all, which is why it goes down here on the outside, because these 5 boys do not have any of the badges, therefore are not up for consideration inside these sets, these circles. Okay, so now I need to fill out this information because the question is asking me to find out how many have both orienteering and cooking badges. So in order to find this out, both orienteering and cooking badge, I have to go 14 plus 17 plus 5 equals 36. So I'll repeat that again. I add up all the orienteering badges and the cooking badges and those that have no badge at all, and I get the number 36. From there I go 36 minus 24 and I get 12. So I'll repeat that again. You add up all the orienteering badges at 14 with the cooking badges at 17 and all the boys that don't have a badge at all. That comes to 36. I then subtract the whole population and I get 12, and that tells me that they have both badges. Now I can figure out how many just have an orienteering badge, so orienteering only. 14 minus 12 equals 2, and I do the same process for the cooking badge. I go 17 minus 12 equals 5. So if you have the whole lot of boys that have orienteering badges at 14, and if you take away the both badges, you will get this as the only orienteering badges. The same thing goes for cooking badges. The total number of boys that have cooking badges minus the boys that have both badges, and you will get 5 left over, and that's the only have cooking badges. If we take that information and we have a question, as we do here, that says how many have both orienteering and cooking badges, it's a probability question, so P bracket orienteering plus cooking badge, close the brackets, fraction line. Now we know that 24 is the population, so 24 goes on the bottom. And we now know that there's 12 that have both badges. That needs to be simplified because that cannot be left as an answer, and it simplifies down into 1/2 because 12 is the highest common factor. It goes into itself once and into 24 twice.